Hello everyone. In this video we're going to be learning about solving inequalities using multiplication and division. So last time we learned about using addition and subtraction. We learned that it was really the same thing when we're solving just normal equations, but instead there was an inequality in there. For multiplication and division, there is one slight difference than when we're just solving normal equations. And so what this change is when we're multiplying or dividing both sides by a negative number, we must flip the sign. So let me show you why we have to do that. So let's say I have -6 is less than 9. That is a true statement. -6 is less than 9. However, when I divide both sides by, let's say, -3, -6 divided by -3, I get a +2. 9 divided by -3, I get a -3. And so now I get the statement 2 is less than -3, which is not true. So whenever we divide by a negative number or multiply by a negative number, to make the inequality still true, we will have to switch it or flip it the other way around. So let's go through some examples where we'll have to maybe do that and maybe not. So the first example I have, n divided by 7 is greater than or equal to -1. So for these problems, I want to solve the inequality, and then I'm also going to graph my solution. So to undo this division, I want to multiply both sides by 7. Since I'm multiplying, I need to see whether I need to flip my inequality. Since I am multiplying by a positive number, I do not have to flip this inequality. So I just have n is greater than or equal to -1 times 7, which is -7. And so when I graph that, I have a greater than or equal to, so that's going to be a closed circle. And I want everything bigger than -7, so I'm going to draw my arrow to the right. So it's okay that there was a negative number on this side. The only number I care about being negative to let me know to flip my inequality is when I'm multiplying or dividing by. So since I was multiplying by a positive number, I didn't need to flip this inequality. Okay, now let's look at this one. So this one, I have 12 is greater than or equal to -3w. So to get that w by itself, I need to divide both sides by -3. 12 divided by -3, I get -4 w. And now this time, since I am dividing by a negative number, I have to flip the sign. So now instead of a greater than or equal to, I'm going to have a less than or equal to. And then since I don't like having my variables on the right-hand side, I'm going to go ahead and switch this around. So I'm going to put my w on the left and the -4 on the right. And then I need to flip this inequality again because I want the open side facing the w. So now when I graph this, I have a greater than or equal to, so it's going to be a closed circle at the -4. Now everything bigger than it, so I'm going to point to the right. I can also check my answer, so if I do plug in -3 in for w, I have 12 is greater than or equal to -3 times -3, which is 9. And when I check that, 12 is in fact greater than or equal to 9. Okay, go ahead and pause the video. I want you to try doing number 3 and number 4. When you think you have it, go ahead and press play. So the answer for number 3 should have gotten x is greater than -9. Since I was dividing by a positive number, I don't have to flip my inequality, and so I'm just going to leave it like that. For number 4, on the other hand, to get p by itself, I had to multiply by -4. So since I was multiplying by a negative number, I needed to flip my inequality, and so it became p is greater than -28. Okay, number 5, I have 5 is greater than or equal to negative 1/10 times z. So this looks slightly different than number 4, but they really are saying the same thing. This is really the same thing as z over negative 10. Both of those expressions are equivalent to each other. So to get z by itself, I'm going to multiply both sides by negative 10. And now since I am multiplying by a negative number, I need to flip my inequality, and so I get negative 50 is less than or equal to z. And then I want to have my variable on the left-hand side, so this is going to become z is greater than or equal to negative 50. And this is what I get when I graph it. Okay, and then for this last one, I have negative 3/5 q is greater than or equal to 15. To get rid of that negative 3/5, I'm going to have to multiply both sides by negative 5/3. And since I'm multiplying by a negative number, I need to make sure I flip my inequality. So this is going to become q is greater than or equal to 15 times negative 5. I get negative 75 over 3.